everyone, welcome back. Hey, what we're going to focus on this week are magnetos. I've seen a few problems in the last couple of weeks, both with installation of magnetos and wiring of magnetos. It tells me there's a lot of confusion out there. So again, sit down, grab your favorite brew, cup of coffee, notepad, etc. These might take a little while, but I hope when we're finished, you're going to have a real understanding of what's going on with magnetos. First, I would encourage you to think about magnetos as ancient technology. So there's nothing super secret or really technical going on inside them. It's just a matter of understanding, one, what makes them work, how you should install them, and then the wiring is really important. So let's take a look at a couple of 6-cylinder mags I have here. And I just happen to have 6-cylinder mags. They are no different than 4-cylinder mags. Here's one that's got what's called a direct drive. All right, so this goes into the cushions on the drive on the back of the engine on a 6-cylinder engine. And in another video I think I mentioned, don't forget to replace those rubber cushions every 500 hours. You should be doing that. They do get hard. They're sitting there in the oil bath all the time. And then here's a magneto that has an impulse coupler on it. All right, now you want to be careful when you're playing with the impulse coupled mag. Turn it the easy way. If you go turning it the other way and it wants to lock on you and you keep turning, that is actually the impulse coupler. And if you continue with that and you have your fingers anywhere around here, you're going to get a good spike. It's going to a good jolt, okay? But turning it this way, it does not fire. So let's take a look at inside the magneto. We're going to come back to that impulse coupling in a bit. Very simple. You have a coil, okay? Inside this lid that goes on here, the top of the magneto cover, where your P lead goes, is a capacitor, basically, that stores the energy. And if you look down inside here, if you can see there, maybe I need to get a flashlight on that. Right there, you'll see what's spinning. See that? Down in there. So that's your magnet that is spinning. And what happens is as the magneto goes around, it's no different than a distributor in an airplane, in a car, except we don't have 12 volts. We're creating our own energy. You can see right here we have points. And as the magneto spins, the points open. Let me lay it down so you can see it. You got a good shot there? Can you see the camshaft coming around and opening the points there?
No, your hand's in the way.
My hand's in the way. Okay, how's that? Okay.
Yes.
See those points? They only open up about 12 to 14 thousandths. They don't open up very much. But that's when the spark happens, is when the points open up. So what's going on is you can see you got a little drive gear here being turned by the connection to the engine. On top of that gear, inside this housing right next to it, ends up being your distributor gear. And this sits here like this, and it goes around and fires on the right cylinder. So what's really important is we get this guy set up properly inside the mag. So when we put it on the engine, we're firing on the proper cylinder when we need the spark, right? So it's pretty straightforward. I'm going to show you right here. If you look on this distributor gear, you'll see a left, a right, and an X. That is for the direction of rotation of the magneto. Does that show up well enough, or do we want a flashlight on it? Does that work better?
Now I can see, yes.
Okay, good. Left and right. And look at those holes next to them. I'm going to show you how we're going to use those holes for. So what's going on is this gear is inside this distributor cap housing. Okay. It spins very freely. And then if we look on top of this, and I'll get a flashlight on there, there's also those same letters, L, R, X. What do they mean? They mean the direction of rotation on the magneto. So you're wondering, where do I find that? You just look right on the mag and it's stamped. See the L right there for rotation? So that's how we're going to pin this mag. And it's very simple. We're going to turn this mag that's assembled. This normally would be all together with the housing on it. This is the way you would be having it to put on the airplane. So we're going to look for the left, right? There's the L. And you're going to need a magneto timing pin like this. We're going to put that in that left hole, right, like so. And then we're going to turn this magneto, putting some pressure on that pin, until it actually wants to go right down inside. Okay. Not do any damage here to this. Okay. There we go. Not quite. I don't have it yet. This is kind of hard to do. Well, normally I'll do this on a bench and a vise. There we go. Almost. There we go. Now we're pinned. Okay? So see this? Well, I guess I didn't get the hole quite. Okay, we got it. It's in there. You can see the magneto is locked. It won't only turn a couple of degrees here. So what's really important is we keep this pin in there. What I'll do is take some duct tape, take a piece of duct tape and put it over top of this pin so the magneto stays pinned while we're going to attach it to the engine. Now the important thing on the magneto going to the engine, and we did this in another video, and I'm going to remind you, if you look right here, okay, it'll tell you what the lag is on this one, okay, because it's got a lag of 35 degrees. All that means is it's going to fire about 10 degrees after top dead center there. We want our engine set up at 25 degrees before top dead center, or 20. The easiest thing to do is take a look at the data plate on the engine. Usually they're stamped 20 or 25 degrees before top dead center. So as I mentioned in a subsequent video, turn that propeller around, make sure you're on compression on number 1 cylinder, and then set it up for 20 or 25 degrees. Then you put the magneto into the engine, clamp it down, and don't forget to pull the pin before you move that propeller. If you don't pull the pin, what's going to happen, you're going to damage this rotor gear inside the engine. It's going to bend. You're going to have to tear it apart to, 1, replace this, and 2, get the pin out. Okay? So that's all how you set up the timing for the magneto. Now, assuming we have it timed properly to the engine, the next failure point that causes a lot of consternation and problem is wiring the magneto. Okay? Magnetos create their own power. Okay? And so we either ground them or unground them to cause them to fire or cease fire. Okay? Now, you can either use a key switch, which is the most common way. Certified airplanes, those of you who are pilots, have been doing that for a long time. And you can also use toggle switches. Now, where people get confused on using toggle switches with magnetos is you want to pay attention. Normally, switch up on is closed. That won't work for a magneto. If you put your switches in that way so they work normally, you'll never start your engine. So you got to remember to flip those switches around so actually on, the switch is in fact open. Open is just the same as having this P lead disconnected. Matter of fact, that's one way to troubleshoot any wiring problems, is just disconnect the P lead from your magnetos. Your engine should run, should start and run. You just won't be able to check for a magneto drop. Now, a lot of engines today on the home built market are either set up with a direct drive mag and 1 impulse coupled mag, or what some are doing is a direct drive mag and an electronic ignition. Okay, so let's talk about the key switch here. And we're going to put a picture in the video here so you can see this up close. But there's some things you got to pay attention to. The first one is the center post requires a ground lead. That ground goes to an aircraft ground up in the cockpit somewhere, or to your central grounding bus. Then you're going to connect each of the P leads center lead, and by that I mean the one that connects right here by this insulated connector, which is actually connecting to the capacitor inside the magneto, is going to go to the left or right terminal on the key switch. The shield of your wire out to the P lead goes right here, connected to, it says ground. So you connect your shield here, and you only connect the shield at the magneto end. You do not need to connect it at the switch end. We want all the electronic noise, electrical noise going back into the mag, not into the cockpit. Okay? So let's say you have a magneto setup on your airplane, dual mags. Very common setup is that you'll have 1 impulse coupled mag and 1 direct drive mag. A way to tell, for those of you who already have them installed, is pull your propeller through, make sure the ignition switches are off. Okay, and listen, if you hear a click, 1 click, you have 1 impulse coupled mag. If you have 2 clicks, some have them set up that way, they were firing pretty close together, you hear a ding ding kind of thing, you have 2 impulse coupled mags. If you end up and you have 1 impulse coupled and 1 direct drive, it's really important how you set up this key switch, okay? So that 1, your engine starts properly and you don't get any kickback or problems. So the trick is, on the impulse coupled mag, the whole reason for an impulse coupling is so the magneto will work at low RPMs, such as when starting. Basically, above 500 RPMs, this coupler disengages, so it's not sitting there firing all the time. Below 500 RPMs is certainly our cranking speed. We want this one to fire because it retards the timing and jerks, kind of accelerates the magnet in there, so we actually fire the Magneto. This one is always set up to fire at 25 degrees. If we allow this one to fire because we have really good cranking speed with our battery, fresh battery, good starter, etc., this is going to fire at 25 degrees before top dead center. You're going to get some kickback on your engine, and those of you may recognize it. Just the prop will stop, you'll get a big jerk, etc., and hopefully you won't get any push rods. Typically, you will break the starter off of the engine housing with that. So what's important is that we disable the direct drive mag during the starting sequence. So how are we going to do that? If you look very closely on the switch, there are a couple of terminals here that are right next to each other. On this one, I think it's the left terminals. What you're going to do is put a little jumper across there. You can see the jumper there. Can you see that jumper? I need to get a light on it. See the jumper? What that jumper does is during the starting process, it grounds the non-impulse coupled mag so we don't get that kickback. It allows only the impulse coupled mag to fire. Now what you want to be careful, especially if you bought a used switch and that jumper's there, if you've got two impulse coupled mags, you don't want the jumper. If you've got, say, a shower sparks, which some people will use now instead of using impulse coupled mags, especially on 6 cylinders, you want to make certain that jumper's not there, so you short out that Magneto or that shower spark system.
Okay, so I'm going to ask a question.
Yes, go ahead.
Zoom in. So the jumper you're talking about is that little piece of metal.
Right there. That's correct.
Okay.
Right
so
there.
It's just a piece of metal.
Yep. It actually comes with the key switch.
Okay.
Okay. So again, make certain that you've got whatever key switch position you have jumpered here goes to the Magneto that you do not want firing during the start sequence. So please remember, that's really, really important, okay? If you have this wired to the impulse coupled mag, your airplane's not going to start, or your helicopter, whatever you have, that engine will not start, okay? And you're going to get some kickback if you allow this one to fire. Right, so the other connections to this switch, you're going to run 12 volts to this switch, to the battery connection. And what's that for, Vic? Because these don't require power. That's for your, if you have a start position on this switch. So you're going to put 12 volts to it, and then another lead is going to go to your starter solenoid. So when you move the switch to the start position, we energize the starting solenoid. Sometimes that confuses people, thinking the battery position here goes to the magnetos. Again, magnetos require no external source. They'll run with these P leads disconnected. The only thing you need the P lead connected for is to actually turn the magnetos off. You ground them so they do not fire. Okay? That cover everything, or you have any questions?
I think I got it.
All right, good luck. Regarding trying to clarify that ignition switch for you, rather than a close-up picture and putting arrows and everything, we actually found a link online, so you'll see that at the end of the video in the comments portion. There's a link, as well as I think we've added maybe a 30-second spot here so you can actually look at the diagram. Maybe for those of you who understand it, just want a quick clarification. Hello everyone, welcome back. Hey listen, had to help a few customers here over the last couple of weeks with some Magneto problems, and it's clear that there's some misunderstandings going on out there, especially with regards to timing a Magneto versus a PMag. So we're going to run through that today. So sit down, this one might take a while, and grab your favorite brew or something and a notepad, or refer to this one when you go time your engine, okay? So let's talk about Magneto timing first. Magneto timing, you can't use a volt ohm meter. You're going to have to use what's called a buzz box. If you've got two Magnetos, you're going to use a dual buzz box. So you're going to clip to each of the Magneto P leads, okay? If you just have a single mag and maybe a P mag, such as we have on this aircraft, you just need a single buzz box. Or you could use this one, the double one, and clip one of these to something that's insulated, like the baffling material, right here. It's insulated so you won't get a false reading. And then you use the black to engine ground and the red to the P lead, okay? Now, the differences where there seems to be some confusion about timing these things is we're always going to work off on Lycoming engines, which is the primary one we're working with on RVs and amateur built, number 1 cylinder. So number 1 cylinder here is, if you're sitting in the pilot seat, it's the far forward right cylinder, okay? And for those of you with aft-mounted engines, it's going to be the cylinder to the right side of the spinner here if you were riding on top of the engine, okay? So you always want to get number 1. And what you want to do is, in the case of a PMAG, we're going to time it at top dead center or close to it, depending on heating problems or timing variables that you want. Most of the time, though, the timing curve will work right at top dead center. So you want to bring this up on a compression stroke on number 1. And there's a couple ways to feel this. You can put your finger, have one spark plug in the top hole, and have your finger in the bottom hole. By the way, for safety's sake, make sure all the plugs are removed, at least one set of plugs from all the cylinders. That way the engine can't fire on you. Because especially in the case of a Magneto, we're actually going to have the Magneto ungrounded, which means it can fire. So you want to be very careful with this prop. Always, always stay out of the arc of this propeller, okay? So spin this around, and what you'll hear as we go through this is a loud click. That tells us that this engine on the Magneto has an impulse coupling, okay? So you're going to hear a click at each of the cylinders. We should get no resistance pulling the propeller through with all the spark plugs out. But as we come up on number 1, we're going to feel compression. It's going to get harder because we got our finger in the hole here, and that's how we know we're on compression for number 1, okay? So watch this. I'm going to, right there, and then it wants to suck as we went by it. So you always want to go past it so the impulse coupling fires. We want to get that fired and out of the way. And then what we're going to do is go back on a Magneto. You come over here, Darian. We're going to come back to 25 degrees. So see the mark there on the flywheel? Can you get that, Darian? 25 degrees right there. Usually there's a mark there. You want to line that up with that starter hole. And you hear the buzz box come on right at 25. Okay? So now we have our Magneto. And I've showed you in an earlier video how to pin the mag before you put it on the engine. So we're going to assume that's already done. What you're going to do is mount the Magneto to the engine with that, and then make sure you remove the pin, okay? And leave it somewhat loose. Bring your propeller up on 25 degrees before top dead center, and then you're going to rotate your Magneto until the buzz box makes the noise that it's making. Then you want to lock down your Magneto and verify it by pulling this through, and it fires at 25 degrees. So that's Magneto timing. Again, 25 degrees before top dead center on number 1. We'll turn this off and get rid of the noise. Now, on a PMAG, the difference is we're going to go to top dead center. So guess what we're going to do now? You're going to look right here on the same timing marks and move this to top dead center 1. See that right there? Got a good shot there? Okay. Now, I mentioned heating problems, etc. What you can do if you want on PMAGs, and you can do this with Magnetos as well, is we can retard the timing a little bit. We've had a lot of success with O360s, and especially the IO390s, of cooling them down a little bit by setting it 1 or 2 degrees prior to top dead center, or I'm sorry, after top dead center. Make sure you hear me correctly on that. After top dead center, it'll fire a little later, and the timing won't be so advanced in high power settings. We haven't had any problems with this one, so we're going to set it at top dead center. So we've already taken this PMAG off the engine. If you remember in an earlier video, there were some service bulletins for the PMAG. Primary ones are to check that end shaft play, which we did, as well as the cotter key. So then it doesn't matter on the PMAG. We can put it on anyway, tighten it down, and then make sure you're on top dead center for number 1. Now the difference on timing a PMAG is it's not mechanical. All PMAGs have a line right here from the manifold intake of the engine. And what you're going to do is power up the PMAG, typically by just applying battery power to the Magneto, and it'll come up in some status with an LED. Typically, if it's already been aligned, it'll come up green if you're on top dead center, perfect. Otherwise, it comes up red. You're going to blow into this pretty hard, and then it'll start blinking, and then you're going to blow into it one more time, and it should go solid green. When it goes solid green, you're done. You're timed where you want it to fire on the engine. Don't forget to reconnect the manifold pressure line. And then you can check it by moving the propeller a little bit off of that timing position, and the LED on the back of the PMAG, which is kind of hard to show you here, will actually go from green to red. All right? So again, that's the difference between timing PMAGs and Magnetos. And so I want to go back and reiterate over here that please make certain you're on top dead center for number 1 cylinder. Otherwise, you can cause some engine damage. I had one person this week, and it was my fault. They asked me to put a Magneto on, and I said, go ahead and set it up for top dead center, or 25 degrees on number 1. And they just moved the propeller till they saw that 25-degree mark. Now you will see that 25-degree mark multiple times as this propeller spins. You want to make certain you're on number 1 cylinder on the compression stroke, and then 25 degrees before top dead center on that Magneto. Okay? Hopefully you got all that. Second ago, right after I mentioned timing the PMAG, I realized I misspoke myself, but we were so long into the video, I said, let's just add this at the end. So let me be clear on the PMAG timing. When you first power it up, that means battery power with the key switch off, so it's ungrounded. It goes into setup mode, and you should get a solid red LED on the PMAG. And once you see that solid red LED, you're going to blow into that tube, into the manifold tube, going right to the PMAG, and then it should start blinking red. So watch for that. Then blow again, and then it should blink green. When you get there, you power off the aircraft, power it back on without moving the propeller, and you should be solid green at that point in time. And then you can check it by just moving the prop a little bit in each direction, and it should go from green to red. And as you come around to each cylinder on top dead center, it should go to green there. Okay? Sorry about that.